Hi, in this program I'm going to talk through the programs in Chapter 3 of your textbook. In this chapter we're interested in reading raw data from external files. In this chapter we look at two types of files in particular, text files, .txt, and CSV or .csv files. And there is another type of file that we'll be looking at in this course, but it's in a later chapter, and that's just a simple Excel file, and we'll actually be using that a lot, but that's for another chapter. Let's begin by looking at Program 3.1. You may notice a slight difference between what I have here and what you see in your textbook on page 26, and that's the in-file statement. The author points to the location on his machine. I point to my shared folder. Before I run this program, I'm going to open up this text file. It's in my shared folder because it was supplied by the author. Here it is. Notice there are two files called my data. One's a .txt file, one's a .csv file. Let's open up the text file, and it should look exactly like what is shown at the top of page 26. We have 5 rows of data. We have 4 variables. The first variable consists of M's and F's, whereas the others are numbers. When we go back to our program, we bring this in by saying, that first variable comprised of letters, M's and F's, needs to be brought in as a character variable. So after the name of the variable, which in this case is gender, we supply a $sign that tells SAS its character. We do not have to do that for the other 3 because those are numeric. Let me run just this one program and we will take a look at what we get. We get, oops, this didn't print out the way it's expected. Hold on just a moment, please. Demographics 1, yes, I changed the name of the file so that we can distinguish between what we're getting each time we run a new program. Let me run this one more time. We get the 5 rows of data, the 4 variables, and we have the names of them as we specified in the code. Now let's move on to Program 3.2 on page 28. If you look at page 28, we can see there at the top of the page, the M's and F's are in quotation marks, and our pieces of information are separated by commas. In this program, we are going to tell SAS to strip the quotation marks and that the comma is our delimiter by using this DSD in-file option. DSD stands for delimiter sensitive data, and if you read on page 28, the paragraph under the program, you'll get to know all of the power that these three letters have. Now, the first program, I named the data set Demographics 1. Here I name it Demographics 2, but the result should be the same. And that file opens up. We have our 5 rows of data with our M's and F's for gender and our remaining 3 numerical variables. Let's go back to our code. We are now on to Program 3.3, also on page 28. And this is just a demonstration of how you could use a file ref. This is similar to a libref within a lib name statement. Here we have a file ref within a file name statement. So above my data step, I have my file name statement. It begins with the file name keyword, and then I choose a name for it. In this case, it's Preston. And then I have my folder location here. And then later in my in-file statement, I've got that file ref Preston instead of the whole folder location. And here I'm naming this Demographics 3. It'll be a 3rd file that I'm creating, but it will match exactly the first 2 I've already created. There we go, our 5 rows, 4 variables, gender, and the 3 numerical ones. On page 30, program 3.4. This is a demonstration of using data lines. You've seen this before. You had a program in Chapter 1 that used data lines, and I showed that program in my libraries video. Instead of using an in-file statement, I just include all of the data within my program as data lines. It is important to organize your information. You want one row of data per line, and you should separate out your variables with spaces. Well, let's compare that to the next program. It's also data lines, but I've got quotes around my gender variable and I've got commas instead of spaces. Well, I can use an in-file statement that points to my data lines instead of to an external file, and I'll use that DSD in-file option that'll strip the quotes away, and it knows my delimiter here. Moving on. We're now dealing with a different data set, and we're in program 3.6 on page 31. We're dealing with the bank data. Let's open that up and take a look. This looks odd. I've got a whole lot of stuff squished together. I've got numbers and slashes and letters. How can I make sense of this? Well, let's compare line to line. 001, 002, 003, 004. That's probably an identifier. 2 more digits, a slash, 2 digits, a slash, 4 digits, that's probably a year. And then I've got M's and F's, that's probably a gender. And then I've got some kind of number after a space here. If all of my variables, well, these first 3 are squished together, that means I don't have a delimiter. How do I deal with this? Well, there are a couple ways. In program 3.6, the way to deal with this is to tell SAS which columns contain each variable. The first one, the 001, 002, we're going to call subject, or SUBJ. The author is choosing to call that character, and we know that that takes up the first 3 columns, so we're going to put 1-3 or 1 through 3. The next one that I thought looked like a date, yes, DOB stands for date of birth. Again, the author is choosing to call it character for now, and that takes up columns 4 through 13. Gender is character, the M's and F's, that's just one column, it's column 14. And the balance, that must be some kind of account, well, it's bank data set, are the remaining columns 15 through 21. Let's run this program and see what we get. Here we go. We can separate out now those things that were squished together in that raw data file. Subject is its own variable, date of birth, gender. Now, balance looks a little odd because if this is a bank, you probably want to see dollar signs, maybe commas after the thousands. Well, let's take a look at our next program, 3.7. We can use, instead of the range of columns, a column pointer, and that's using the @ symbol. So the way that SAS reads this is it says, all right, we will start at column 1, and we will read the first 3 columns, and we're going to call that a character variable. Then we'll begin at the 4th column for the DOB variable, and it's coming in a particular in format, MMDDYY10 dot. Those dates, let me go back to bank. We start here 10/21/1955. That's MMDD. Now there are 4 slots here for Y, but the total number of spaces this takes up is 10. So we use what's known as the Let me find it again. Starting at the 14th column, we have gender, which is character, but only one column in width. And then starting at the 15th column, we have our balance variable, which is a total of 7 for our width. And then we can run this program. Again, we've got not only the balance that doesn't seem to be displayed quite the way we might expect, the DOB, the date of birth, isn't displaying quite the way we might expect. How do we deal with this? Well, that's using a format statement here in proc print. We tell SAS to print out the date of birth using the MMDDYY10 format and to apply $signs to our balance. Let's run this. Now it's displaying in a way that makes a lot more sense. Going back to our programs, we're now to program 3.9. The only difference between 3.8 and 3.9 is the choice of format for the date variable. Instead of the MMDDYY10 dot format, we're using the date9 format. And let's see how that differs. The month is spelled out as the 3-letter abbreviation rather than as a 2-digit number. Moving on to program 3.10 on page 36. We're dealing with a different file. This time it's called list, and we can see in about the middle of the page on 36 that we've got 4 variables again, and these are surrounded by quotation marks, and these are separated by commas, and we need to bring this into SAS. And one way to do this is to say, well, I'm going to use the DSD option. That'll take care of my quotes and my commas. And I'm going to specify my informats here in my input statement, but instead of using column pointers or the range of columns, I'll use this colon modifier here, and it actually had I think a different name. Oh, it's called an informat modifier that tells SAS to use the informat supplied, but to stop reading the value for this variable when a delimiter is encountered. You can read more about it on page 36. So again, it's the same variables. We've got a subject, we've got a name, we've got a date of birth, we've got some kind of monetary type of variable. Previously, it was a balance. Here we're dealing with a salary. Let's run this and see what we get. Good. No quotations around the names, no commas, and because we specified a format statement for the salary and the date, we can see these displayed in a way that makes sense rather than the way we were seeing previously with the bank data. Now for program 3.11, we could separate out the informats from the input statement at the very beginning. We can say that we want the date of birth to come in with this format and the salary with this dollar format, and then we can leave those off of the input statement. That might be a way that makes a little bit more sense to you. But again, if we want it to be displayed using a particular format, we need a format statement. Let's run this. All right, there we go. And I'm going to leave it up to you to read through the information on page 38 for program 3.12 with this ampersand. All right, that does it. Good luck.